I wanted to pick this problem this week for solution analysis for a couple reasons. We haven't really talked about mid-segments. We haven't talked about mid-segment theorem. We talked about vectors, but they kind of come in and out. So this would be a nice time for us to kind of remind ourselves of what they can do and what they represent. And I like this problem too because there's no values. And I think that in the first semester, we really valued values. We really used a lot of coordinate plane. We calculated distances, Pythagorean theorem, distance formula, GeoGebra gave us all kinds of values. But it's important to understand that many of these geometry truths were actually first discovered without measurements. They were discovered and understood by mathematicians who only used a compass and a straight edge, so not even a ruler. So it was about the relationships between certain figures and angles and lines, more so than what their value actually was, which I think is really important. I mean, when we talk about congruence, we don't, and this is just an example, like we don't need to know what an angle measures, right, to know that it's congruent to another angle. There might be some truths, geometric truths that allow us to prove that no matter what the angle measures, it will be congruent to some other angle. Anyway, that's why I thought it'd be good to talk about this, because I would like to see us trying to implement more what's called plane geometry, Plane, plane geometry solutions, which means that we're not using any values. We're just using truths about the geometric figure in front of us. It's also called Euclidean geometry. So try to incorporate this into more of your solutions, especially the ones that don't have any values in them, like this one. So draw a triangle ABC, let M and N be the midpoints of AB and AC respectively. So I've already kind of set this up. Here's AB, here's ABC triangle, AB, AC, here's M and N respectively. And when I did, just a little side note too, when I did in GeoGebra, the midpoint, it automatically did D and E because those are the next letters. And then this is a little thing, but I changed it to be what the problem actually had as M and N. Sometimes we get a little lazy and we don't do that. And then it comes back to really confuse us and our reader, because now we have a D and an E in our diagram when the problem had M and N. So I hope that makes sense. So take the time to make your diagram reflect the givens completely. So express, remember this sign means vector, express BC and MN in terms of vectors U and V, where U is AB and V is AC. So I'm showing that here. Maybe I'll actually even label this vector, so I'll put its name here. Oh, it's choosing the segment. 1 second. Here's vector U. So why don't we actually get that? And that's a nice little tip there too, is like if you click and it's not showing what you want it to show, let's see, show label, show name, you can just go to that bar over here to show that. So this is vector U with midpoint M, and see how it's not clicking that one. This is vector V, show label, perfect. Again, the reason I kind of show this too is so it can improve your skills with GeoGebra. Now I can move this around and because I've set this up at using the midpoint tool, and you'll see some other things I did. I can move these points around, and so yes, there's values here, but try to disregard them. I'll tell you why I had the values for these in a second, but honestly, disregard them. This is confusing to look at all these. In some ways I could hide this, but I don't want to, because I want you to see some things. I want you to see what the first line says, but not the values. I purposely didn't put this on a coordinate grid. Okay, so we have midpoints, we have the vectors. So let's attack this question first. Express BC in terms of U and V, where U is AB and V is AC. Well, we can do that. Okay, so we need to write an equation, basically, or an expression that gives BC, the vector BC, so let's visualize that for a second. The vector BC would travel from B, so it would have a tail at B and a head at C. Remember, vectors, it matters the letter that comes first and the letter that comes second. So let's see if we can figure that out. BC. Okay, well, I've actually created something here that gives the result of adding particular vectors. So when we add vector U, so this vector right here, and this vector right here, we get this blue one, this one down here. So how do you add vectors anyway? Well, you just add their components. So vector U, we add their x components, so 18 something and 9 something makes 28 and something. So that's your x component. Oops, I got a little email here. And then you add their y components, so negative 1 point something plus 4 point something gives you about 3 point something, right? So can you visualize, right? Whenever you see a vector, you should almost kind of visualize a right triangle, right? You should visualize a horizontal component and a vertical component. A horizontal component and a vertical component. If you add the horizontal components to each other and then the vertical components to each other, you get the vector addition result. So if we simply just add U and add V, we're not going to get BC. Do you guys see this? This is like, and this is why I included the measures here. This is way too big of a magnitude. Remember, the magnitude is the length of the vector. And not only that, but it's like pointing in the wrong direction, right? It's pointing like from lower left to upper right. We want something that goes from like bottom right to upper left. Okay, so something, hopefully your intuition is telling you something must be negative here, right? Because if we're adding these two vectors and we're getting something too big, there must be a subtraction going on. And you can probably kind of see that, right? Because this vector's x component, if we subtracted the x component of this one, we'd probably get an x component that would shrink. Do you see that? Because this x component is bigger than this x component at this point, right? I mean, this could all change, right, as we change. And we'll see that no matter what, in this case, we're not going to get BC. All right, so let's try that. So let's try to take V, and what's cool here is instead of going AC, I'm going to have it go CA. So I just flipped it around. Okay, this is promising. Do you see that? I flipped it by writing C to A instead of A to C. Now I have the tail at C and the head at A. So this is nice. I'm getting the same magnitude. But the issue here is my vector travels from top left to bottom right. You see that? Otherwise, it would be a perfect match, right? And I was trying to get this to like superimpose on this, but actually I probably could have figured that out. But that's all right. I think you guys can see that this is the same vector, except it's going this way. So hopefully your intuition says, well, let's just keep this one the same then. And let's switch this one around. Let's see what happens. Okay, so now this travels from B to A, and we have it. We have the magnitude is correct, and we have the direction. So vectors are always about distance, direction. Notice that, oh, this is nice. We're getting to match right here. See that? Okay, so that does BC. So in other words, we just are proving here, right? We're doing it kind of using software, but also the numbers don't really matter, right? Because this holds true no matter what the value is. We're kind of showing that dynamically. So we just showed that if we take the opposite of U, right? Remember, we're doing the opposite of U because instead of AB, we're doing BA. And we add that to V, we actually get BC, right? We get BC. So I'm actually going to stop this now. I feel like I've been talking for a while. I will share this with you and see if you can try and come up with, and again, I just use like vector tools. I didn't use a whole lot of crazy stuff. See if you can come up with a solution to the second part of this where it says express mn in terms of those vectors. So mn is this one right here. All right, see how that goes? So mn, I'll actually draw that in. So the vector mn. And this mn is actually called the mid-segment of this triangle, right? It's one of the mid-segments. There's actually three. Can you visualize it? One here, one here, one here. And what a mid-segment is it's just the segment that travels from the midpoint of one side of the triangle to the midpoint of the other side, and it has a special relationship with BC, in this case, with the side parallel. Notice how these would be parallel. And what you're doing is you're kind of proving that here. All right, have fun with that. I'll share this with you guys.